Hello and welcome back, everyone, to Unit 2 of Coding in ICD2O. This is like your introductory for computer science. So, first things first, we're going to do Boolean variables named after Charles Boole, and that just holds true or false values. And then we're going to learn about operators, and then we're going to get into comparisons after that. So first things first, let's make a file. I'm just going to make a file over here. I'm going to call it boolean.py. Okay. Now I need to make some bool variables or Boolean variables. For this, I'm just going to do Python is awesome. Set that to equal true with a capital T. And then I'm going to have Python is lame and make that equal to the opposite of true, which is false. So now we have a true and a false variable. If I wanted to, I could just print one of these variables. So I'm just going to save. So Control S, F5, and I'm going to run it. And I'll just print true or false. Not super useful, but we can also print some text to add some context to what we're doing. Just as an example, Python is awesome. And then add Python is awesome. Perfect. Then I'm going to copy this line. I'm going to paste it, and then I'm going to change a few things. I'm going to change this to Python is lame, and then change this variable to the Python is lame variable. And the reason for that is I just want to show you that you can do true and false. So if I save and run, we'll see here true and false. Okay, pretty straightforward. So that's just how you can hold a true or false value, which is sometimes useful. We don't usually use this very often. Usually we'll just determine if something's true or false and use that. But sometimes it's useful to use a little bit of memory to track a true or false value. You can think of this as like in a video game, if the character is grounded, so is grounded is true, and they press the jump button, then you would make the character jump. So this is one instance where you might use a Boolean variable. Okay, now let's talk about Boolean operators. And in Python, they're really, really intuitive. I'm just going to comment out this line first. So if I want to see if Python is awesome and lame, well, I could use the two variables. And Python is lame. So now it's going to check if Python is awesome and Python is lame. So both have to be true in order for this whole statement to be true. It's only going to return true or false, not true and false. So both have to be true for an and to be true, but not both are true, so we get false here. But if I change this to an or, so I'm going to change this to an or. Save and run it. We get true because Python is awesome or lame. It's either or, so Python is awesome, so it ends up being true. Overall, the whole statement's true because one of them is true. If neither are true, then it ends up being false. If both are true, then then the overall statement is true. So this is how Boolean operators work. There's one more that I'd like to show you that inverts everything. It's called not. So you could say Python is not awesome or lame. So Python is not awesome or lame. So when you put not there, it converts this into from true. So the opposite of not true, or not true is false, right? It converts whatever's coming after it into the opposite. So true becomes false and false becomes true. So we have not true or false. So not true is false, so we have false or false. In this case, we should get overall false because both are false. Because Python is awesome. It's not awesome. You could do double not. Python is not awesome. Now we're just getting silly. You shouldn't do this in your code, but I'm just doing this to show you. And we get true again because it inverts this, which we remember this is false, but a not is a double negative and it cancels itself out just like it would in math. Okay, now that we've seen that, I'm actually going to make a new file and I'm going to call it comparison.py. Because we're going to learn a little bit about comparison operators, which we can use with number variables. As opposed to just using Booleans, which hold true or false, we can determine if an expression is true or false. So I could print, let's say, height equals int input. What is your height in centimeters? Odd way to measure height. Very unusual, but I forgot a question mark and a \n to make sure it goes on the next line. Then I'm going to print. You are tall enough to ride the roller coaster. I don't actually know what the height requirements would be. So let's just see if height is greater than, say 120. So 1 meter and 20 centimeters. That's not super tall. So if they are above 1 meter and 20 centimeters, they are tall enough to ride the roller coaster. But if, let's say they're 1 meter, you are tall enough to ride the roller coaster. False. So false because they're not tall enough. Let's try it again. If I type in 180 this time, you are tall enough to ride the roller coaster. True. So it is true. Now, we could change the requirements. We could make it so that you have to be exactly 120. So equals, and this is where students will actually get mixed up. If you want to check if something is equal to something, you do double equal sign. If you want to set a value, you do 1 equal sign. This is one of the most common errors that I will get. Oh, syntax error right there. It's not liking it. If I try to run it now, it still doesn't like it because it doesn't know what to do here because it thinks I'm trying to assign something. So I need to put this in another set of parentheses, save and run it. And now it knows what to do because it needs to evaluate this to give the computer a value. So sometimes you need to add some more parentheses. What is your height? If I'm 120 exactly, I'm not old enough to ride. I am tall enough to ride the roller coaster because it's not. And now it's stuck in a loop. I'm just going to clear those again and then try to run it. Height is defined though. I've been having this issue. There we go. And if I enter 180, I am not tall enough, even though I'm taller. So this condition actually doesn't make sense in this context. You can make it less than, because if you're short enough, maybe there's a height restriction instead of a requirement. That means that you have to be under a certain number. So you could do less than, or you could do less than or equals to. That's how you do less than or equals to. You could do not equals to. So there's a height that you're not allowed. If you're 117, for example, if you're 1 meter and 17 centimeters, you're not allowed to ride the roller coaster. But if you're Stuart Little and you're like, I don't know, 6 centimeters tall, you are allowed because you're not 1 meter and 17 centimeters. So there's lots of different comparison operators we can use to determine these things. We can even combine these. So we could check to see if height is between two things. We can do this by checking to see if height is greater than or equal to. So let's set a minimum requirement. Let's say at least 1 meter. And the height, I am running out of space here, is less than 200. So they can't be 2 meters exactly. And you know what? I'm actually going to do this here. By pressing enter, the code will still work, and it organizes it so that we can read it here nice and neat. I'm a little zoomed in, so it's a little bit easier for you to read on, say, a projector or on a smaller screen. I could zoom in more, but that gets a little bit too much for me to handle. So now you are tall enough to ride the roller coaster. If your height is above or equal to 100 centimeters and your height is less than 200. So we need a number in this range. If I say 199, it is less than 200 and it's greater than 100. So it's true. I can check above. Oh, my console has been acting up. I can check above. If I'm 200 exactly, I am too tall because it's not less than or equal to. It's just less than. So I can't be equal to it. And I could be 100, but let's just do 99. False. I am not tall enough because 100 is not greater than, 99 is not greater than 100. So that will not work. So you can use and, you can use or, you can use not, and you can compare these. The last comparison I want to show you is comparing two different names. So I could have name 1 equal Kenny, and name 2 equal Kyle. They both start with K, so if we were to determine alphabetically which one comes first, we can determine that it's Kenny because E comes before Y, and we have to look at the second letter, right? Python handles it in the exact same way. If we think of, sorry, let me just print this out. Print name 1 greater than or equal to name 2. And contrary to what the grading system might tell us, I'm just going to add 180. False. Okay, you know what? I'm just going to comment out this code. All right, I forgot my keyboard shortcut, but to comment out a block of code, you highlight it and you press Control/. Not backslash, just Control/. Anyway, to compare two different names, you treat it the exact same as you would numbers, except think of it this way. A comes before B, so B is greater than A because it's later in the alphabet. The same way that 2 is greater than 1 because 2 comes after 1, right? So we have to think of the order that way. So it's kind of inverted from, say, the Ontario grading system where A is the highest level of achievement. Well, A is actually the lowest letter of the alphabet. So we have to twist how we think about that. But if you just think alphabetically, it makes more sense because A, B, and then C, and so on and so forth. Anyway, let's run it. Let's see if Kenny is greater than Kyle, even though this has nothing to do with their character, but their names. Yes, Kenny is actually less than Kyle. Kenny is not greater than Kyle. So if I save and run it again, it's true. And this is strictly to do with their names, nothing to do with their character. So it's just checking to see if Kenny's name comes before Kyle in this sense because it's less than. If I had it the other way, I'm checking if Kyle comes before Kenny alphabetically. And that's how this works. So you know now how to use true or false values, use comparison with numbers as well as with strings. This should be enough to get through your daily activities, and I will see you in the next one.